All right, the next one that we're going to look at is the light sensor. Okay, the light sensor is extremely important, okay, because it's going to bring us to how to follow a line. So let's start with light sensor. And I'm going to window tile left right. All right, in this one I've set up a front panel just in case I want to look at what the light values are, 0 to 100. And we're going to use the poly display with line 4 and the poly sensor. Okay, so all I did, I haven't targeted this yet, so if I do target to NX to the EV3, then I get a smaller thing. It's a little less cumbersome. So we're going to first obviously create a while loop. Then I'm going to put a light sensor, and that's going to come in IO, poly sensor, or sensor right here. And in this sensor is going to be the light sensor. So you're going to read NXT light. Now, some of the EV3s are different, but light is not one of them. So although it says read NXT light, this NXT works for an NXT brick, which is our old kind, or an EV3. Works with the new color sensor for the EV3, and it also works with the old light sensor with the NXT kit. So if you're in the honors group, you'll have an EV3 color sensor that can function as a light sensor. If you have the NXT kits, you're going to have both a color sensor and then you're going to have 2 light sensors besides. So don't feel you're getting shortchanged if you're not in the honor section. We're giving you a top line kit as well. All right, we want to do read with light on. Okay, now when you're doing this, you have to know where on your robot have you plugged in your light sensor. So this program is going to assume you plugged it into port number 3. If you didn't plug it into port 3, then it's not going to work. So visible items, label, port 3. I guess that doesn't add much. All right, now if you're wondering, hey, how come you're not putting that thing across like this? And the reason is I could, although it's redundant, because since I have a data line going to the poly, Labview knows it has to read the poly sensor first. So there's already a program, a flow direction set up here. Poly display, I did create line 4. I added an indicator here for the front panel, light sensor value. This isn't necessary to run, but if you want to be able to see the values right on your screen, your front panel, in addition to the display on the EV3, we'd run this in debug mode. So I could run it, but I don't have a light sensor connected. That's about all I need to say about the light sensor. But when you run this, what you're going to find is ideally values should be between 0 and 100. But depending on the light conditions, you may find that it only varies, let's say, between 40 and 60. And to run our line following program in the future, we're really going to want to have our values scaled from 0 to 100. Okay, so that's where the VI known as the light calibration comes in. Now I have put the light calibration into the ENR161 folder, but I'm also going to show you how I made it, okay, and to describe what the heck was going on. All right, so let me close this one. And I'm not going to save anything. And I'm going to open up my light calibration. And it is not here, so I'll open existing, go up here, and I'm going to go to light calibration 2 because it took me 2 versions to optimize it. Okay. All right, so what this program does is it has 2 while loop blocks. In the first block, it's going to communicate with the program user and it's going to tell them the first thing, place the sensor over a black object. It's then going to send the program flow into a poly display and say minimum light value is. It's going to put some text out on line 4. And then on line 6, it's going to display the poly sensor value. Okay? It's then going to give the person a message, press the right button when you're done. So after you've put it over the black and things have settled down, you're going to hit the right button. Okay? And that's what we have down here, the poly sensor button. You hit that right button, it's going to put a true. It's going to stop this first while loop. I have put the pink here to force the flow to do the first one, then the second one. If I didn't put this magenta here, it may go in either order. So let me show you the second one. The second block's very similar. I'm going to come up here on the poly display. I'm going to write the thing, place the sensor over white. Then I'm going to put a new max value is. I'm going to put a clear button, press the center button, and then I'm clearing out the poly display when I'm done. Okay? To exit the second one, I'm going to put the enter button. Now, what happens is a couple values are going to come out of this, which represent the slope and intercept that will allow us, under these light conditions, to change the raw light sensor values to scaled values between 0 and 100. Okay, and you can read how this works, but just know that this instructor came in on a Saturday and spent his whole Saturday in here so that you'd have just a beautiful calibration routine that's going to make your robot better than anybody else's. Okay? Now, you don't have to create this one, although if you wanted to make it, you could. And but I have this VI. Don't save. I have this VI right in the M courses. Remember, in ENR, ENR161, WADIC, Lego resources. So you can take your light calibration right from there and drop it into your program. Okay? So that brings us to our next VI, which is going to be the light sensor scaled. Okay? So let's open existing light sensor scaled. So this is how we're going to use the light sensor calibration. Okay, it's the same almost inside as the regular light sensor, and it's going to run indefinitely. But the difference is we're going to bring this light calibration VI in. Okay, and notice there's two outputs. There's an intercept and a slope. And what we take is we're going to take our light sensor value, multiply by the slope, and add the y-intercept, and that'll give us scaled light values between 0 and 100. Now, how do you get this in? Now, once the light calibration VI is somewhere where you can access it, you can right-click, and I'm going to target this to NXT. Okay, so I can right-click, and I can select a VI right up here at the top. Select a VI, and I can come in and I get my light sensor and I double click on it, and there's my light calibration. Okay? And once I bring that in, you can see there's two. Let me just hide that for a second. There's two outputs. There's a y-intercept and there's a slope. Okay? I guess I could have spaced those out. And you're just going to take those and bring them in and create some tunnels into your while loop. Okay? I really didn't like that tunnel. Anyway, it's got two tunnels. And you can move these tunnels up and down to suit your needs. Okay? So you add those in, and now what's going to happen is when you run this program, it's going to ask you questions on the front panel that are going to tell you what to do. It's going to say put this light sensor over the black tape. When you're done, press the right button. Then it's going to say put it over a light surface. When you're done, push the middle button. And once you do that, then it's going to enter this while loop and stay in here forever. On the front panel, we're going to have raw value and scaled value, so you can see if you didn't have the calibration what your light value would give you. And then on the right you'll see what the scaling does, and hopefully you're going to see the scaled value be about 0 when you're on the black surface and about 100 when you're on your bright surface that you use for your calibration. So let me just show you this. I don't need the second calibration. So you're adding in a few displays. The scaled light sensor, the raw light sensor. I guess I could to connect these together with a with these lines, but it seems to be working okay for me. It's going to have to do this first, although it may, whenever it does this poly display, I really don't care, because as long as it gets done. And the same thing for the scaled light value, because I'm not putting things all on the same line. But you could, if you really want, if you're feeling like things aren't working right, you can come up here and you can make that one go there and this go here, and then do this last if you really wanted to force it. But I don't see a need where you're going to have to do that. Okay, so but if you do have trouble with things not executing in the order, you can bring those magenta lines to force them to go in this order. Okay, but really not necessary. All right, so hopefully that scaled light value will prove that the light calibration is not some kind of hoax. Okay, so it's not like Bigfoot or the Loch Ness Monster, but it really does work. All right, next thing in line, now that we have the calibrated light source, and I'm going to just close this and don't save. All right, we're going to go into our line follow on-off. Okay, this is a simple on-off line following program. And I do have some things that can communicate with the front panel, but this program is set up to either communicate with the front panel if you use debug mode, or it can just run and give these values onto the actually it doesn't give any values on the front display, but while you're debugging you might want to do it in debug mode, but it can also run autonomously. So let me just show you what we've got here. So you can see it on the big screen, and I've put explanatory comments. We got a big loop right here. Excuse me. We're going to calibrate before we get into the loop. We're going to read the poly sensor. We're going to do some mathematics. By the way, this is an add, and this is a multiply. Okay. This should scale the light sensor to between 0 and 100. Okay. Now what this does is you can set an edge value to anything you want. Okay. Most of the time I'd say probably start with an edge value of about 50. Okay. It's then going to see if the light value is above or below 50 by taking the light sensor scaled light sensor value and subtracting 50. Okay, if this is greater than 0, that means you're on a white line, and it will turn on your right motor and turn off your left motor. Okay, so these selects are going to determine which of the motors are going to be on and which are going to be off. So here this is, it says power 75, but that speed may very well be 0, okay, because that's actually the speed input. All right. In fact, let me just sever that for a second, and let's see. Yeah, so that is the power. the 75 means that if you don't connect anything to it, it's going to use 75 as the value. The motor speeds can be anything from 0 to 100. Okay, so if we were on a real bright line, there would be 100. We're going to just go 50. You can jack that up if you want. So I'm going about half speed, but you're going to find half speed is plenty fast. If you're having trouble staying on the line, then you just decrease the speed maybe down to quarter speed, 25. If you want to hug like more of the middle of the line rather than right on the edge of the line, you can decrease this down to 30. Sometimes the navigation works a little bit better this way. All right, so I've got a lot of explanatory comments in here, but that's the big picture. We calibrate, we read the light, we check to see if it's above or below our edge value, we adjust our motor speeds over here, and then we continue and go read another light sensor. And this continues forever or until you hit the top left button on your brick. So that's our first one, and what you should see with this, if you're pushing the speed at any bit of rate, is you're going to see kind of like a lot of jagged driving, kind of like, I don't use impaired driving is what it would look like. All right. Now let's go to the next VI, which is the proportional one. Okay, by the way, these motor ones, they come from the I/O, and there's move motors. Okay, and then you bring that in. Well, and it brought in power. All right, I was looking for, where exactly is this motor on VI? This is an older, it came from the an older version of Labview, but we can get the same thing by right-clicking, going to I/O, and we can just go and bring the move motor in. As you can see, it looks almost the same, although this one has a power or a constant speed. So you want to use a constant speed on this. So I'm going to just take this off. Well, I'll just sever that for now, and I'll just bring that to the side. Port B. Remember that we're using port B. All right, just bring this one up here. Now, this motors that's what you do your port to. Okay, and it didn't like that. Come on, you don't have to punish me. Let's see. I'll try to hit escape here. Okay, there we go. All right, it doesn't want me to use that. Okay, so we won't. We won't. All right, let's just get rid of this port B. Delete. Delete this. All right, so this is what the new EV3 motor looks like. So motors, we're going to right-click. We're going to create a constant. Whoa. That's something new. All right, let's see. It says up here, whoa. Okay, I guess it lets you stack more than one motor up there. Okay. All right, unselected. So we're just going to put our port B right here. Okay. Like I said, it looks like it can stack more than one motor on this function, but we're just going to use it like this. All right, so this is what yours is going to look like now. So I'm just going to, the other one is port C. So I'm going to get rid of that and get rid of all this and put in a move motor. Hitch my power into this wire. Go right click, create a constant. What happens if I create constant down this way? Create. No, I'll just create constant. All right. And this one is going to be port C. Okay. So you have to make sure that your right motor on the right side of your tribot is connected to port B, and the left motor is port C for this to work. Okay. So I'm going to download this thing. I don't have a motor connected, and just see that it's okay. is no longer connected. Yeah, I know. It's shut down. Your EV3, if you don't use it for about 10 minutes, it'll shut down. Okay. But that is the proportional control. And this old motor on VI is no longer anywhere to be found. But you'll want to use, it doesn't even give us an ability to say what it is. You're just going to have to know. But you're going to want to use constant speed, not constant power. All right. So there we go. That is your line follow on off. So let's save that and close it. And calibration, don't save. All right, now let's go to something a little bit more sophisticated, line follow proportional. All right. Now, this is going to give us more choices for how we can control the motor and get a much faster and smoother ride. Okay. All right, so let's take a look at what's still the same. So you're going to use the light calibration. You're going to read the poly sensor. You're going to show what the scaled value is. You're going to have an edge light value. You're going to have use your poly display to display things. All right. Then what we're going to do is this edge value 30 is really the target value we want to get to. The further our light value is from 30, which is like somewhere inside, let's put it 50 to be just to start out with. So 50 would be when your light sensor is halfway on the black line and half off the black line. So how far off you are will determine the correction. So this subtract and multiply and then the speed, all this stuff has to do with creating a speed that is between, it's not necessarily turning both motors on and off. It could, if you were all the way over on one side, it would turn one all the way on and one all the way off if you're all on the white, if you've lost the tape. If, however, you're all on the black, it'll put one on and the other one off. But if you're some proportion on or off, it'll proportionally drive these motors, partially. So if you're veering off the line a little bit, it'll speed the outside motor up a little bit more and slow down the inside one just a little bit. So if you're a little bit off, it makes a little correction. If you're off by a lot, it makes a big correction. Once again, like I showed in the last VI, I'm just going to replace this. Maybe I can just replace. I'm not going to go to all palettes. Let me target this first. So target NXT so I get the smaller menu. I right click. Okay, now we're ready. So I'm going to replace with IO move motor. Let's see what it does. Come on, baby. See, since it's different control, it did it. And it even kept that. But if you do it, you're probably going to have to go up here, right click, create constant. Well, what if I do it this way? All constants. Whoa! I don't know what that is. Don't do that. -1. All right, bad idea there, folks. So create the constant it wants, and you're going to go port B here. And then same thing here. I'm just going to sever that line right there. Replace this one with the current move motor. Get rid of this. Create a constant. And choose port C. Alright, since I never want my motors to go backwards, okay, I just want them to drive forward. I found this a little VI called in range and coerce. All right, so you're going to put a recommended speed based on your correction algorithm. You might come up with a number, if you put too high a gain or something, with a number greater than 100. In fact, if it goes to a number greater than 127, Labview or the power thing is going to think that it's a negative number, and it's going to try to drive the motor in reverse. So to prevent that from happening, I use this coerce in range. So if, let's say, this add thing comes out and it's something between 0 and 100, that value just gets passed out on the coerced X line. And it's like this thing isn't even here. But if the add gives you a value of 120, then the coerce will only give you 100. And if you get something that's negative, it'll stop it and replace it with 100. So this is like a fancy select function that says, hey, if your value is not within the range, send the 100 out, or send the 0 if you're on that side. Okay, where do you find the in range and coerce? You find it by going into programming, probably comparison, no. Structures, no. Numeric, yeah. Okay, so you find it in the programming numeric. That's where it is. If you want to learn more about it, you go to the context help and it'll tell you all about it. But I found it and it was a little handy thing. So you're going to use the coerce, in range and coerce. All right. And like I said, it makes speeds go from 0 to 100. I've got a big explanation here as to how it works. In your program, remember, you can just double click and maybe put some comments. So if you want to remind somebody that, hey, this is the scaled value, scaled light right there. That's why we did that. But there we go in all its glory. I hope things work as well as they worked for me. Hey, one last thing on this line follow proportional. I forgot once I put that in there to put this to constant speed. It was left on power. So make sure you go to constant speed on those two, and everything should be great. All right, movie's now done. Thanks for stopping in.